How you doing today, Mr. Bledsoe? It's me, Kyrie. I'm doing another review on multiplying exponential expressions. Okay, so what we have here is an expression. 12 times 12 to the third power times 12 to the fifth power equals 12 to the eighth power. I got this answer because 12 times 12, well, it stays the same, since it's the same base, it stays the same, so you just add it along. And then 3, you add the exponents. 3 plus 5 is 8, and that equals 12 to the 8. What some people might do though is they might multiply 3 times 5th and multiply 12 times 12 and get a completely different answer, which is the wrong thing. Next problem. Okay. Alright, so we have 4 to the square root of 12. It's 4 to the second square root of 12 minus the square root of 12 of 75. And the first thing you would want to do is the first thing you would want to do is factor 75 and factor your 12, because it'll lead to your answer. Well, because in that perfect square, so 12, 2 times 6, 3 times 2, and 75 would be 3 times 25. That'll be 5 times 5, and voila. After that, you would just write down the number, and then the square root of 2 to the second, because it's 2 of those, so you would just say 2 to the second because of the second power here, times 3, subtract 5 to the second times 3 also, because you have 2 5s and a 3, so you would just do 5 to the second times 3. Alright. Then after that, you pull out your you pull out the things that are equal to be under your square root's radical sign. So that means that since this right here is an imaginary 2, which is also right here, that means that this 2 will pull out because it's so it'd be 4 times 2, while the 3 stays because the 3 doesn't have an exponent, which would be equal to 2. Which is 8 with the square root of 3. Subtract 5 with the square root of 3. And then you would subtract, the square root of 3 would stay the same because it's the same base, and then you would subtract 8 from 5 from 3, which would give you 3. So that means your answer would be 3 to the square root of 3. What some people perhaps might do is when they get here to this part, they may, after they factor, they may put things that are not equal to 2, so they might just put a 2 and 3 and 2 times 3 times 2, which won't be able to be pulled out and won't have the right answer. Same goes for here. Next problem. Okina. Okay, so the next problem, we have multiplying radicals. Multiplying radicals, we have 4 to the square root of 8 times 4 to the square root of 32. And then I'm guessing you would just, like the last problem we was to do, you would factor it, and 8 can go into 4 and 2, which can also can be used as 2 and 2. And there's an imaginary 2 here. Don't forget that, you guys. So that'll equal out to 2 to the square root of 2 times 2. For this one, 32, you can get 8 and 4, I believe. But better yet, 16 and 2, where this can be simplified up to 4 and 4, because 4 times 4 is 16. And then simplify the 4 and the 4, and you'll get 2 and 2 and 2 and 2. So you would have 2 to the square root of 2 times 2 to the square root of 2 times 2. And okay, wait a minute. Oh, okay. So after you have that, you would set up your equation, which would be the first one right here would be 4 to the square root of 2, because an imaginary 2 there, to the second power times 2. You will pull this out by lamb, and this would become 4 times 2 to the square root of 2. 4 times 2 is 8. 8 becomes 2 times, this will become 2 to the square root of 2 to the square root of 2 times 2. So this would look like something like 4 to the square root of 2 to the second power, 2 to the second power times 2. And what you would get is what you gonna get, I'm gonna work it out over here. 4 times 2 times 2, and then this will be under the 2. And 4 times 2 is 8, and 8 times 2 is 16. So you get 16 left over with 2. And 8 times 16 is 32. Is it 32? Okay, sorry, technical difficulties. So you will have 32, and this right here becomes a 2, and then that would cancel out. It's the same base, so it'll just be 2. So your final answer is 32 to the second power of 2, and I am done. Mr. Bledsoe, you have a good day.